part 2 ng ating series sa ating problem solving sa hydraulics, which is yung ating fluid flow measurements. So, start na tayo sa ating problem number 1. So, problem number 1 natin, calculate the discharge in liters per second through a 100 mm diameter orifice under a head of 5.5 meters of water. We will assume, we assume that the coefficient of contraction is equals to 0.61, and then yung coefficient of velocity is 0.98. So, kukunin natin yung ating discharge, right? So, yung ating discharge, ang kanyang equation formula in terms of orifice is yung ating discharge, coefficient of discharge times area ng ating opening times square root of 2GH. Okay. So, yung ating C, or coefficient of discharge, makukuha natin yan with the formula na CC times CV. Okay? So, yung CC natin is 0.61 times CV na 0.98. So, ating coefficient of discharge na C is equals to 0.5978. Okay. And then yung area natin, ang area natin is with the diameter na 100 mm, so area equals to pi over 4 d squared. So in terms of meters, meron tayong pi over 4 times 0.1 squared. Okay. Tapos yung h natin is yung head of water. Meron tayong value na 5.5, 5.5 meters. Yung G is yung ating gravitational pull na 9.81. Okay, so meron na tayong C. Meron na tayong data sa area and then sa H. So, ipang input natin, makukuha natin yung ating discharge. So, input na lang natin ha. This coefficient of discharge na 0.5978 times sa area na pi over 4, 0.1 squared times square root of 2 times 9.81 times sa head na 5.5. So, yung ating discharge, paki-input sa calculator, ang lalabas na value is 0.04877 meter cube per second. So, ang sabi dito, yung discharge natin is in liters per second. So, i-convert natin siya into liters per second. So, i-times natin sa 1,000. Ito ang ating conversion. So, liters per cubic meter. So, cancel, cancel. Meron tayong 48.77 liters per second. So, ito yung ating discharge value in terms of liters per second. 48.77. Okay? Problem number 2. So, problem number 2. An orifice has a coefficient of discharge of 0.62 and a coefficient of contraction of 0.63. And we will determine the coefficient of orifice. So, coefficient of discharge, di ba yan yung ating C? So, 0.62. Coefficient of contraction, yung ating C sub C, which is 0.63. And then, yung coefficient of velocity, Yan yung ating unknown. So, paano natin makukuha yan? So, sa ating problem number 1, nakita nyo, di ba? Yung ating C is equals to CC times CV. So, since may value na tayo nito, may value tayo nito, isa lang yung ating unknown, so, madali natin mahanap na. So, ipang-input na natin, 0.62 is equals to 0.63 CV. So, input sa calculator, shift solve, ang ating C sa V is 0.984. So, ito yung ating answer for our problem number 2. Okay. So, next, problem number 3. So, problem number 3. The discharge through a 75 mm diameter orifice at the bottom of a large tank was measured to be in 1,734 liters in 1 minute. If the head over the orifice remains constant at 5.5 meters, we will compute the coefficient of discharge. So meron tayong, di ba, yung ating actual discharge is equals to coefficient of discharge times doon sa theoretical discharge. Okay. So with this, makukuha natin yung ating coefficient of discharge, di ba? So other formula ng ating actual discharge is equals sa volume over time. Okay? So, yung volume natin na 1,734, pero dapat in terms of cubic meter, di ba? So, i-divide natin siya sa 1,000. Okay? Over sa time natin na 1 minute, pero dapat naka-second, di ba? So, yung 1 minute natin, times natin sa 60 seconds. Okay? So, yan na, nakapang-convert na natin. So, yung Q natin, yung actual discharge natin is, may value tayo na 0.0289 meters cube per second. Okay? Next, kukunin natin yung ating theoretical discharge na Q sub T. So, ang formula natin para sa theoretical discharge is area ng ating vessel or ng ating, what is this, pipe. Oh, yes, pipe. Ano? Area ng ating orifice times square root of 2GH. Okay. So, ipang-expand na natin ha. Ipang-input na natin ang mga values. So, pi over 4, yung opening ng ating orifice, ang kanyang diameter is 75 mm. So, 0.075 squared. Okay? Times square root of 2. Ang ating G is gravitational pull na 9.81. And then yung ating head na 5.5. Bakit nga ito yung ating ginamit na formula? Kasi, na-mention dito, magre-remain constant yung ating head. So, with that keynote or keyword na remain constant, ibig sabihin, meron tayong theoretical discharge. So, yan siya. Pasok siya dito. So, yung ating theoretical discharge, ang value is 0.04589 meter cube per second. So, meron na tayong theoretical discharge, meron na din tayong actual discharge. So, makukuha na natin ang ating C. So, input na lang natin ang ating mga values. Meron tayong actual discharge na 0.0289 is equals dun sa ating coefficient of discharge C times theoretical discharge na 0.04589. So, input sa calculator, shift solve, may value tayo ng ating C na coefficient of discharge na 0.63. So this is our answer para sa ating problem number 3. Okay, next problem tayo. Problem number 4. So problem number 4, determine the diameter of orifice. Wait lang. Determine the diameter of orifice that permits a tank of horizontal cross-section 1.5 square meter to have its liquid surface drawn down at the rate of 160 millimeter per second for a 3.35 okay. Hindi ko pala na-edit. 3.35 ito ha. So wait lang. 3.35 meters head on the orifice. Then we will use C, yung coefficient of discharge na 0.63. Okay. So yung solution natin for this problem, yung discharge through the orifice is equal doon sa tank's cross-sectional area times the drawdown rate. So yung ating discharge is equals sa area ng tank times dun sa drawdown. Velocity drawdown. Yung velocity doon. So, meron tayong area ng tank na 1.5 square meter. Okay? Tapos, yung ating drawdown na velocity at the rate of 160 mm per second. So, dapat in terms of meters, so meron tayong 0.16 meters per second. So, yung ating actual discharge is 0.24 meter cube per second. So, next, kukunin natin yung ating diameter, di ba? So, di-determine natin yung ating diameter doon sa ating orifice. So, ang gagamitin natin na formula is yung discharge is equals to coefficient of discharge times area doon sa orifice times square root of 2GH. Expand natin. So, discharge is equals to coefficient of discharge times pi over 4 d dun sa ating orifice squared times square root of 2GH. So, itong ating diameter, ang ating unknown variable. So, pang input na natin yung mga values. So, meron tayong 0.24 na discharge is equals doon sa ating coefficient of discharge na 0.63. Then, pi over 4 d squared times square root of 2 times 9.81. And then, yung head natin na 3.35 meters. So, since isa na lang yung ating unknown variable, yung ating d. So, input sa calculator, shift solve, ang ating diameter is 0.245 meters or 245 millimeters. So, ito yung answer natin sa ating problem number 4. So, next. Problem number 5. So, last problem for this video. Abordas mouthpiece, 150 mm in diameter, discharges water under a head of 3 meters. We will determine the discharge in meter cube per second. Wait lang. Meter cube per second, and the diameter of diameter of the jet at the vena contracta. The coefficient of Borda's mouthpiece are CC equals to 0.5 and then yung CV na 1.0. So for this, we will determine the diameter doon sa ating vena contracta. So ang ating formula dyan is yung ating area sa ating vena contracta is equal dun sa ating coefficient of discharge times the area dun sa ating mouthpiece. So, i-ano lang natin, i-expand. So, pi over 4 diameter dun sa ating vena contracta is equals dun sa ating coefficient of discharge, which is from the CC times CV na 0.5 times 1.0 times area dun sa ating mouthpiece. So, meron tayong diameter na 15 mm. So, pi over 4, yung D natin is 0.15 squared. So, with that, makukuha natin yung ating diameter. So, pi over 4D squared ha. So, yung diameter natin, i-shift solve na lang ito sa calculator. Ang lalabas na diameter is 0.106 meters. So, in millimeters, meron tayong 106 mm. So, yan yung ating diameter sa vena contracta. Okay. So, ano yung ating vena contracta? Diba, kumbaga ito yung ating vessel, ito yung ating orifice, yung opening. And then, lalabas yung water, diba? At some point, meron tayong pinaka maliit na diameter dun sa ating flow. So, that part, kumbaga, yan yung ating vena contracta. So, yan yung diameter ng water ha. Nung pinaka maliit na diameter ng ating fluid flow. Yan yung ating vena contracta. So, yan yung ating hinanap. So, next, kukunin natin yung ating discharge. So, discharge natin is ang formula is equals to coefficient of discharge times area. Area ng ating orifice ha, hindi yung vena contracta. Since yung vena contracta is yung ating liquid yan. So, area ng orifice times 2GH. So, yung C natin is 0.5. Yung area ng orifice, pi over 4. Yung D is 0.15 squared times square root of 2 times 9.81. Head na, asan na yung head natin? 3 meters. 3. So with that, ang ating discharge value is 0.0678 meter cube per second. Okay, so this is our answer para sa ating problem number 5. Okay, so dito nagtatapos yung ating problem solving para sa ating fundamentals of fluid flow. So may part 2 pala itong ating fundamentals of fluid flow. Okay, see you on the next video. Thank you for listening.